Are you looking for a realistic talking character generated using AI? If yes, then in this video I'll show you exactly how to do it, step by step.
You see, I am cooking 2 different workflows for creating talking characters and then a couple of voice cloning workflows to pair with LTX. So let's begin.
In this first workflow, I will be using the Identity LoRA with the LTX model. The red section here is about selecting the diffusion model and LoRA. Similarly, all these red-colored nodes need your attention. These are the links to the older videos covering different topics on LTX. You can watch if you are a beginner. Below are the links to the diffusion models, and then the FP8 model. I have downloaded the FP8 model, but I will not be using it in this video. I will be using the GGUF model, the Q5 model. You can get good results with a larger FP8 model. However, the challenge is with a system with low memory, so I will be using the smaller models. Links to download the different models are given below. You can get the Q4 or Q6 model from there. This LoRA node has a distilled LoRA selected. The distilled LoRA will be needed only when you are using the dev version of the model. I will not be using that LoRA because I have selected the distilled model in both the nodes. There is another LoRA, and we cannot skip this. This Identity LoRA is trained to generate the talking characters. There are 2 options here. You will find the same on Hugging Face. The LoRA is uploaded by comfyUI, and out of these 2 Identity LoRA, I am using the AIvideo LoRA. More details on this Identity LoRA are available on GitHub. The LoRA now supports the LTX model, and a demo is shown below.
Identity LoRA can generate voice and environmental sounds, such as this guitar, now with LTX 2.3 and comfyUI support.
There are 2 files here, and the first is this celeb VHQ. This LoRA has been trained on celebrity faces. I am sure celebrity video is possible with this LoRA, which I do not promote. Let's look at another LoRA that is about talking characters, and this LoRA has been trained on talking character videos. The training data here looks diversified with multiple different languages and people from different age groups. The 3K here should be the number of training steps. The download link for both has been given in the workflow. Download and save it inside the LoRA folder. The LoRA requires a specific type of prompt, and the template for the same has been given on the right. First, you will need to describe the scene and the appearance of the character. Second is the speech you want the character to speak. And third is the vocal style and the sound in the background, like the vehicles in a traffic or any musical instrument. So the model and the LoRA goes into this reference audio node. This node is new in this workflow, which makes the Identity LoRA work. The model with the LoRA also goes into the second stage of the workflow, as we saw in the default workflow for LTX. This section is about the clip text encoder and the prompts. Here you can select the safe tensor file of the Gemma model. Links to the files are given. You can also download the FP8 model from the link given below. I am using the smaller GGUF file, the Q4 file. The other quantized file can be downloaded from the link given below. On the right, we can see the positive and negative prompt nodes, and I am using a separate node because the prompt generated using GPT is large. The prompt here describes the visuals, and then the speech, and then the sound. Both the positive and negative prompts goes into the same reference audio node. The node also takes the reference audio to clone a person's voice. This means the speech we type in the prompt will sound similar to the person's audio given for reference. The VAE here is to introduce the given audio file into the latent space. And this identity guidance scale will increase the effect, but explaining these settings will take a separate video. So let's keep it as it is. The audio file uploaded in this workflow is on the left, and this model is used to separate the vocals and instruments from the audio file given. The link to download the file is given. Download and save it in the diffusion model folder. Upload the audio sample here, and I'm using the first 10 seconds of the given sample audio file. Make sure to trim long audio file. Keep the length between 5 and 10 seconds. A larger sample will produce a bad result. Activate this node to separate the instruments. I'm not using it right now because the audio file given does not have any instruments. Preview the audio file before it goes into the workflow here. The same audio goes in the node group below because I was testing how it works without a LoRA. With the help of a text-to-speech workflow, I generated the audio file with the exact speech mentioned in the prompt, and then instead of giving the empty latent audio, I gave the latent speech. The result generated had the lips synced, but using LoRA makes the result look somewhat better. So you do not need to use these nodes. After the audio, we need to upload the character's image. The image is resized, and the resolution here is 320 pixels because I was trying different settings before making this video. The same resolution is used to define the size of the empty latent video, which is like a blank canvas for the video frames. The image of the character given goes here, affecting the latent video frame with a strength of 0.7. So we are done with the empty latent video and audio with the character's image. Now we need to look here, not the FPS, but the length of the video. Right now it is at 15 seconds, but do not confuse it and change the audio length above. This audio is just a sample to make the speech sound similar. The VAE files are selected below with the download links. So this is the first stage of the workflow, and everything goes into this sampler. The output from the sampler goes further to the second stage. The second output, which is named denoised output, can be decoded and previewed. So let's generate a clip using the first stage of this workflow. This is the third attempt due to the prompt given by GPT. The speech here is about a bunny speaking, and what it says is, "This is your final warning. Give me the snacks now, or I will start chewing everything, starting with your favorite things." This took a few attempts for me, so make sure to check the response by GPT. After the prompt, the sample audio given is here, and then the image. The length of the video is 11 seconds because the speech given in the prompt did not fit in the 10-second clip. And this is the result.
"This is your final warning. Give me snacks now, or I start chewing everything, starting with your favorite things."
This workflow and the files used in this workflow will be shared in the folder named Workflow 1. This is the result generated, and if you drag the result on comfyUI, it should give you the exact same workflow. Now I have a decent result generated, so I will activate the process nodes in the second stage and run the workflow again. You see, the process began from this node here, because the seed ID in stage 1 is fixed. This model is being used to upscale the video in latent space. But you should note that the model used is different from the one used in the default workflow. So you can download the latest file from the link given below. It took 45 seconds for one step on my 4060 Ti 16GB, which is 380 seconds for the result in the first stage. Also, I forgot to mention that the video resolution was increased to 512 pixels. Now it will be increased further in the second stage. Time taken for the second stage is again around 380 seconds, and the final video resolution is 1024 by 896, which looks good to me. So that was the two-stage workflow. Now let's look at the second workflow. This is a simple approach to get somewhat similar result. The workflow is similar to the Stage 1 workflow we saw just now, but with two small differences. One is with the LoRA, and the second difference is in the sample audio section. This diffusion model, clip files, and the subject's image require no explanation. The LoRA used here is the Talking Head V1 LoRA. Download and save it inside the LoRA folder. The LoRA strength here is decreased slightly. You need to check if it works for you. Here, you do not need to use a complex prompt. The old man prompt worked for the SpongeBob video you saw at the beginning. In the audio section, the audio file uploaded here is the speech I want the character to speak.
You see, I am cooking two different workflows for creating talking characters and then a couple of voice cloning workflows to pair with LTX. So, let's begin.
This audio was generated using text-to-speech workflow. Previously, we used a sample audio file to clone and generate speech from LTX. Here, I have given the speech an audio format, so the workflow needs to work on the lip sync only. The video duration here is 12 seconds. Keep it close to the audio length uploaded. The rest is the same. Audio goes ahead and connects to the audio latent connection with the video latent. Everything goes to the sampler, and the video is generated. I have a different audio file that should work with a bunny. The audio length is 25 seconds.
Listen very carefully. This is a friendly warning. You're going to give me snacks right now.
I should also be changing the prompt. This will work, but it's better to describe the bunny's angry expression and movement. Length of the video needs to be 25 as well, and I think the rest should work fine. I got the result in 490 seconds, but I had to generate it again. And then it took 533 seconds. The 25-second audio file was not covered in the first attempt. One word at the end was missing, so I added one more second and made the length 26. And then the result generated was acceptable.
Listen very carefully. This is a friendly warning. You're going to give me snacks right now. If you don't, well, I can't be held responsible for what happens to your carrots, or your furniture, or your entire kitchen. You have 5 seconds. Starting now.
Now let's have a quick look at the workflow, which I have used to generate the audio file for the bunny. I am using OmniVoice, and it did a decent job of cloning the reference voice. The workflow is simple. In the manager, under the custom node, I will show you the installed node I have. I will search for Omni. These are the two node groups I have installed. You can have both. One of these should work. I will open both in a new tab, and this is the one that worked for me. This did not work, but now it should be working because changes have been made in the project. Let's begin with the project that worked for me. Copy this link. Open CMD in the custom node folder. Check if Git is installed. If you're doing this for the first time, then search for Git for Windows and click here to download the installer. The installation is simple. Just continue with the default option and default path for installation. After installation, restart the CMD and check again. If it says Git not found, then go to the System Environment Variables and then in the Advanced tab. Open the environment variable, then under System Variables. Click Edit to edit this path. Inside, there are multiple paths, but you may not find the Git path. You need to add this path. Click the New button and then add a new entry. Then click OK. Restart the CMD, and now it should show you the version. Copy the link, type git clone, and paste the link. In my case, it says the project already exists because I have it already. Now we need to install the requirements of this project. To do that in comfyUI Portable, you need a command, which I will share. Check the description. You can close the CMD, and then you need to open it again on this folder. Copy the command and paste it. I made a mistake in the folder's name. After correcting the folder name, it worked, and the installation is in progress. Restart comfyUI, and the project should work. Similarly, you can try the second project. The steps are the same. This third step is about installing the necessary packages, like we did just now. I will share the command for this as well. Make sure you open CMD in this folder and run the command. The command works when the project is present inside the custom node folder. I have both of them because I was planning to make a video on TTS. I will make a dedicated video later. On the first run, this node will download a model automatically, so it will take some time. Here I had to change the value to decrease the rate of speech. Let's understand this in detail in another video. So that is it for this video. The workflow will be in the description. I hope the video was informative and useful. I wish you an excellent day.